Okay, I think we're recording. So we're finishing up these work problems. Here we have that Maria can clean an attic in 10 hours. Jessica can clean the same attic in 9 hours. How long it would take them if they worked together. So this is back to the first problems that we started. The first three problems or something like that of this homework. So let's let x, our variable, be the number of hours needed for Maria and Jessica to complete the job. So let's emphasize that this is when they're working together. Alright, so during that first hour of work, what part of the job is Maria doing? What's her contribution? Well, if she can clean the attic in 10 hours, then as each hour goes by, she's getting 1/10 of the job done. Now, what about Jessica? She's going faster. She can get the job done in 9 hours where it took Maria 10 hours. So on a per hour basis, she's getting 1/9 of the job done. We don't know the total time, the time that it takes for them working together, so we called it X. So on an hour by hour basis, if it takes them X hours to do one job, then they're doing 1/x of the job per hour. So on the left hand side, if we add these fractions together, let's get a denominator 90 by multiplying by 9 over 9 and 10 over 10, and 9 plus 10 is 19. And let's take the reciprocal of that, 90 over 19. Let's go to the calculator. 90 divided by 19 to 2 decimals is approximately 4.74. If we did try to look at the 90 over 19, it would be 4, and then the fraction left over would be what? 4 and 14/19. So this guy, 4 and 14. But who's going to say that as far as hours go? Most likely they're just going to say 4.7, if that. I guess some people might just say, hey, just under 5 hours. All right, so some little sentence that says that they can complete. Maria and Jessica can complete the job in approximately 4.74 hours. All right. The last one. Drum roll, please. Jack can install a new deck in 16 hours. One day his friend James helped him, and it only took 6.86 hours. Find how long it would have taken James to do it alone. So let X be, we're still working in hours. The number of hours needed for James to complete the job, let's emphasize alone. So Jack, since it takes him 16 hours to do the whole job, on a per hour basis, he's getting 1/16 of the job done. Now, during that first hour, we've got James that's also working. We don't know the total time that it takes James, so we call that X. So on a per hour basis, he's getting 1x of the job. But we know together that since it only took him 6.86 hours, that on a per hour basis, they have 1 over 6.86 part of the job done. Now 86, this is 86 hundredths, and I can convert this to 6 and 86 hundredths. I could take half of each of those, 43 over 50. So 6 and 43 over 50 is a mixed number. Change that to an improper fraction, then take the reciprocal. I'm just going to work with the calculator and decimal numbers. I'm not going to do all that. I don't see the need to force us to do that. Oops, now, better pay attention to what I'm doing. Later in the evening, I'm even more prone to silly mistakes than... Sometimes I make these videos very early in the morning. Alright, let's go to a calculator. We've got our 1 divided by 6.86 minus 1 divided by 16, and I need to take the reciprocal of that, which raising it to the negative first power to make the exponent positive one, it flips the fraction. So x is approximately 12.01 if I've been rounded it to the nearest hundredth. I don't really have any reason for doing that. I suppose I could have been doing it to the nearest tenth or even the nearest integer, but I'll just keep consistent. I'll tell you what, on quizzes and tests afterwards here, I'll tell you how far to round it, how many decimal places to round it. Alright, so James can complete the job in approximately 12.01 hours. Alright, so hey, I believe that's it. And I hope that helps. Let me know one way or the other, and I will talk to you later. Bye.